We are very excited to have George Salazar from NASA. He works at the Johnson Space Center down in Houston. Be a cool place to work. Um, George is the chief engineer of the Human Interface and Systems branch. He does some super cool things. We've had the opportunity to meet him and talk about his work over the past several actually months now. Talked to you last couple months, and does some amazing work, especially as NASA looks forward, going to the moon and Mars. So what we're excited about here is going to have George do his presentation. A couple rules or things to know about. There's a Q&A, a question and answer capability. It's in Slido, which is over on the right side of your screen. You can use it to submit questions for George. You can submit the questions at any time, and then at the end, he will answer them. We also are recording this session, so if you want, you can turn off your camera. We'll record it with that privacy in mind. George, with that introduction, we are really pleased to have you present and take it away.
All right. Thank you, Peter, and thank you for inviting me to speak to the students. Hello, students. Hopefully, you'll get a few things, key takeaways in terms of my presentation. And so what I want to do now is, let's see if we can go into sharing my presentation, and hopefully you can see that. And so that's, basically I work at the Johnson Space Center. There's different centers, and perhaps you've learned this perhaps with other presenters, but NASA has different centers, and each center has its own responsibilities. Human interface, human systems is part of Johnson Space Center because we have the crew here. So hopefully you can see my next slide that shows topics. And the topics going to give that I'm going to be talking about in the next 25 minutes or so is my background, path to NASA. So path to NASA, I keep getting this question asked by students: how did you get to NASA? And I can tell you that it wasn't originally my objective. And you'll learn this as I progress through my presentation. But needless to say, I will show you how I got to NASA, and then I'm going to talk a little bit about the moon and the proving ground and some of the challenges to overcome. And what I'm hoping to do here is kind of inspire you guys to understand that there's a future for you all in terms of STEM, in terms of human exploration, in terms of working with NASA and contributing to the NASA mission. And then I'm going to recommend some NASA, join NASA, and how can that happen? And I'll give you a few tips on that, and then closing remarks. So first up is growing up. So a little bit about myself. People want to say, who's this person that's talking, who's speaking here in front of me. And so I grew up in Corpus Christi, Texas, which you see that as a little green dot. Let's see if I can get my laser pointer here. And so that's a green dot right there. And so Corpus Christi, Texas is kind of known for Selena Quintanilla, who was a very famous singer back in the 90s. And unfortunately, tragically, her life was taken too early in life. I have to say that one of the interesting things about me is that I was not born with a silver spoon in my hand. Sometimes they say, "Oh," students will say, "Oh, you were, you came from a well-to-do family. You became an engineer and all that." Well, not true. I know many engineers that grew up in somewhat of a economically challenged neighborhood. I did. What you're looking at there is how I grew up in, or where I grew up in Corpus Christi. It was a shotgun house, basically 25, 14 to 15 feet wide by 25 feet long, 3-bedroom house. Um, it was somewhat challenging. Where's the bathroom? There was no bathroom inside this house. It was outside, and that was always something that I hated to do because it was kind of scary at night going out to the bathroom, and there were frogs and animals and all kind of stuff like that. But needless to say, that's what I grew up in. And right below there, you see a junkyard, and you say, "Well, my gosh, what's a junkyard have to do with an engineer?" Well, I have to say this was a starting point for me as far as engineer was concerned, because that was an opportunity to go over there and grab stuff and learn about things. Me and some of my buddies that grew up in the ghetto, or as we call them in Spanish, the barrios. Um, Things to build and learn about. We took a lot of wood and built our first tree house, and our first tree house was not all that fantastic. We didn't know anything about stress and strain and thermal dynamics of wood in different temperatures and all that. Needless to say, our first tree house crumbled as we got into it. But we learned a lot. I learned about a toaster and how it operated. uh, I have to say that I almost got shocked in the process, but it was a learning experience. And what you're seeing there is a shoe shine box. And I did not come from a very well-to-do family, so I had to raise money to kind of buy things like, for example, comic books that I loved, and other hobbies, if you will, that basically I wanted to pursue. And so I used to shine shoes back when gentlemen used to wear leather shoes. And you can see there, 15 cents. I still have the shoe box. It was my uncle that helped me build that. And I have to say that it taught me a lot about responsibility in terms of trying to make money, and how to use that money wisely. So what you're looking at here is different things that I did over the years. I was starting to build models like this. Here's an example of F-104 model that I built. I built that when I was 5 years old. I loved working with my hands, and as a result, there were other things that I started to do, working with my hands. So I used to buy soldiers, and soldiers were very cheap at the time that I was growing up. There was no such thing as superheroes. So guess what? I said, well, what if I take soldiers and convert them to superheroes? So I would take soldiers in certain positions, put a bunch of bubble gum on them, a little bit of glue, a little bit of, let's say, paint, and I would create superheroes. Now you notice Wonder Woman. Well, Wonder Woman, there was one of these soldiers that ended up being Wonder Woman. Where did I take the hair? I took the hair from my sister while she was asleep, and she never knew that until later on. But it was fun doing all this. Now, as far as let's say electrical engineering, because that's my major, or that was my major in college, I have to say the slot car racing, when I was age of 10, I started to learn about slot car racing. So slot cars basically operate on a motor that's 12 volts, operated by what you see, these two little slots here. And these slots have a plus and minus 12 volts that basically feed current to the motor of the car. And these guys right here, which are little high-speed controllers or handheld controllers, were basically the variable resistance. So if you pressed harder and harder, you could decrease the amount of resistance, which increased the current, which was fed to the motor, and the motor would go faster and faster. If you took your hand or your finger off the control handle, the car would stop. And so this was basically, circuits 101. And I loved it. I didn't understand what was going on until later on, but I understood the concept of how to operate these and things like soldering, making my own cars out of copper tubing and things like that became part of, let's say, my learning experience, if you will. At the age of 10, my dad bought a donut shop, and he was very fortunate to have bought that donut shop. It was somewhat, let's say, the ticket out of the ghetto, if you will. And so we had a little bit more money. We were able to actually buy a house for the first time growing up. And so there's a picture of me. I think I was 15 years old that I was taking a picture with my mom, and unfortunately, I cut out, being a teenager, you didn't want to see yourself with your parents. But needless to say, here's a picture of me at the donut shop, and I was already making donuts at the age of 10. I learned the business very well. In fact, that was very beneficial because the following year, my dad suffered a heart attack, and so I was running the business while going to high school, and it taught me a lot of things about time management, responsibility, work ethic. And speaking of work ethic, going to the next slide is my family. And so what you see here is my grandparents that had no education, but very strong work ethic, very strong family, the love of family. And they instilled that on my dad. There's a picture of my dad with my mom. This is the picture of them uh, at I think it was in Ohio. They were they did migrant work during the summertime, and both of them were just the work ethic was very strong in them. Interested enough, kind of a funny story. My mom could outdo anybody in picking vegetables and fruit. And one gentleman told my dad that you married a machine, not a human being. There's a picture of my family. There's my daughter, her husband. That's my wife, my granddaughter, my sister, my other sister, my nephew, my brother-in-law, my brother back there. And this is a picture of my other daughter and her husband. That's a picture of us, and you can see two pictures here. This is my wife in Mitsubishi, and the other one in South Africa, Can Campana. We love to travel. Of course, pandemic has kind of curtailed that, but we hope to pick that up in the coming years. And let me just point out a couple of things that my dad had just a fourth grade education. My mom was had second grade education. In fact, she became an orphan when she was 10 years old, and actually spent quite a few years in San Antonio in the orphanage there. So, in terms of education, as you can see, there was not much of it in my family. So, school performance. Elementary school, I was a B student for the most part. I attended 5 different elementary schools while growing up in Corpus Christi. Why is that? Because my dad would lose his job, and it's kind of a long story that it would take too long to explain. Needless to say, eventually I went on to from elementary school to middle school. I was a C student in middle school, and I was getting caught up in the wrong crowd, to say the least. I have to say that I lost my incentive to learn more about science. I used to love that in elementary school. Obviously you saw that I enjoyed, learning and, doing hands-on work, and I started to lose that to some extent in middle school. In high school, there's a picture of W.B. Ray High School in Corpus Christi, Texas. Eventually ended up graduating 475 out of 605 graduating seniors. That means that I was lower 20% of the class, which is not all that impressive. A pretty poor performance. And in fact, my last year in high school, the counselor told me that I should get into auto mechanics as my career. As you'll see, as you maybe well know or can infer, that didn't happen. So life after high school, we moved to Houston, and during this time, I worked in various jobs. I worked in construction, which actually was very beneficial because my uncle taught me quite a bit about woodworking. I sold books door to door. I hated it, and but I was trying to make some money. I went back to working donuts, Chipley Donuts, and I ended up working at Kmart too as well. Trying to pull 2 or 3 jobs together to try to earn as much money as I could because I guess the work ethic was very strong in me again, instilled by my parents. I tried to make a change in the career. I found out that I can't be 50 years old or 60 years old and still trying to do construction, still trying to do things at Kmart. I needed to do a change, so I applied at different jobs. I first applied at Xerox as a tech repair technician, but when they gave me the test, oh my gosh, I had no clue what they were talking about. I opened up the book and it had nothing but digital logic. Later, I learned about what digital logic is, but initially, I had no clue what it was. And they showed all these things like AND gates, OR gates, input, output, logic tables, and all this. But that's how these Xerox copier machines operated. And that was digital electronics was very big at that time. But I had no clue what that meant. Needless to say, I failed. But then I didn't let that stop me. I tried IBM, and IBM actually was no different to some extent. I do have to say that I did quite well in the electrical part, but not very well in the mechanical part because the IBM machines were much more mechanically driven, so to speak, rather than electronic driven. And then I tried getting into a technical college and basically trying to do radio, TV, and repair. And it just didn't work out for me. I didn't like the college. I didn't like the way they were teaching. I was very dissatisfied, so I quit. Actually got married at that time and then kind of laid low, if you will, for a few months. After I got married, my wife encouraged me to go back to school. But so I said, let's see how this works out. I tried to see how was the best option, and so it was a road. It was a crossroads, if you will. Do I want to succeed or do I want to fail? And I have to say to myself, I want to succeed. Looking back at my family, looking back at my heritage, it became very important to me to become better and uh, to um, to make my family feel more proud of me, if you will, in furthering my family. So in terms of education and what have you. And so I decided to pursue trying to get back into college. And I took my SAT scores and they were terrible. And so that was a community college that accepted me on a probation basis, Harris County Community College, and I have to say that the counselor there was just absolutely outstanding. He saw a lot of potential in me, and he said, "Look, George, I think you would probably be interested in electronics technology, and maybe at one time later in your life, you may want to become an engineer." So I pursued electronics technology, but again, I was on probation. What does that mean? That means that I had to have done B or better for 4 classes that I took. And I did. I made a average, but I had to actually accelerate myself because there were some classes that I was deficient in. My math was terrible, my English was terrible, and so I had to take what they call remedial classes, which means, going back to square one, if you will, and learning about basic math, learning about basic English. Be that as it may, I took the challenge, and within 2 years, I graduated with my Associate of Applied Science in Electronics Technology. I transferred over to the University of Houston, which initially I started out in technology, wasn't happy with it because I didn't feel like I was learning a lot. Luckily, I joined an organization that helped me understand, the ropes, if you will, of going from a small college to a university. And so I transferred over to electrical engineering. Now, this is kind of somewhat of a funny story, was that uh, when I was transferring from College of Technology to engineering, I had learned about a lot of people in engineering transferring from engineering back to College of Technology. And because engineering was too hard, so I said, what am I getting myself into? But needless to say, I was able to hang in there and graduate. Not with all a fantastic grade point average. I'll say more about that later. You see a picture of me graduating with my bachelor's of science in electrical engineering. That's my firstborn daughter. That last semester was pretty challenging because she was born. Uh, 21 years later, I got my master's in systems engineering at Southern Methodist University. I was admitted on probation. Oh, that probation term comes back to haunt me from junior college. Well, that's because I didn't have a very high rather undergraduate degree in electrical engineering in probation. So I I had to accept the challenge, and within the semester, I was accepted on a full-time basis and graduated with an A average. You see an arrow pointing to my daughter because my daughter took a picture of me again graduating with my master's 21 years later, and there she is on my right-hand side, your left-hand side, and then to the left-hand side is my daughter. They're both successful in college, and none of them became engineers, but my daughter on my right-hand side or your left is now a nurse with a master's, and my other daughter is a project manager, very well accomplished project manager, in fact, in the city of Austin, Texas. And so, how did I get to NASA? Well, obviously, the U of H graduation was a biggie, um, but I along the way, I also did some work as a repair technician in counting calculators. I learned quite a bit about repairing calculators, quite a bit about test equipment, quite a bit about electronics troubleshooting procedures, if you will. And then I tried to get into NASA as a cooperative education student while going to the University of Houston. When I applied, the GPA was rather high, and I didn't make it, and so I got declined. But GeoSource accepted me, and so I was accepted as a manufacturing engineering technician at the GeoSource, and so that coupled with the repair technician helped me get into NASA because when I interviewed with NASA, the gentleman, Mr. Robert Brown from the Crew and Thermal Systems, was quite impressed with the background I had in terms of hands-on experience. And so the GPA, he said, it's okay, but we really love your experience. And something he shared with me that I'll never forget, it was that the Apollo space program, one of the reasons why it was successful was that a lot of the engineers that worked on the Apollo space program that first took us to the moon was kind of filled with a lot of engineers with hands-on experience. Even the entry-level engineers had already had some kind of engineering experience. So really, that's how I got to NASA. It wasn't a straight line. I just just happened to have had the right credentials, if you will, getting to NASA. So what do I do at NASA? I'm the Human-Computer Interface Technical Discipline. Human-Computer Interface Technical Discipline Lead. So what does that mean? So that means that basically I'm responsible for a lot of the human interface stuff that goes on between the different programs. So what you're seeing there is a picture of the SpaceX. If you're familiar with SpaceX, that's launched quite a few human-rated missions. I was responsible for the display system on that, and I work with SpaceX in terms of doing testing, certification of the system for the actual flight system. I've also been working on the Starliner, the Boeing system, and you can see here's an astronaut working the interfaces. So the work that I'm involved with is how the human controls the system through some kind of interface, computer systems, if you will, whether it's touchscreen, whether it's a rotational hand controller or switches or whatever. That's my responsibility. But I'm also getting involved with the human lander system. In addition to interfaces, I'm also involved with other aspects dealing with human interfaces, like for example, some experimental work dealing with olfactory development system, which olfactory basically means smell, trying to develop ways of helping astronauts cope with deep space depression. And so this is a Texas space, this is actually Texas State in San Marcos that was working on this. But there's also things that I'm involved with that are actually not really interfaces per se, but hardware that's needed for interfaces. And there's something called graphics processing unit. You're looking at all these pictures right now as you see in my presentation, all this is being generated by a graphics processor on your computer system. But these computer systems do not operate very well in space, and so we have to figure out how can we make them operate properly in the space environment, and that's something else I've been involved with. Here's a picture of some of the work involved with radiation tolerant GPUs at University of Texas at El Paso. And then there's also intelligent lighting. So lighting is very critical for humans in deep space because lighting is very important in terms of what we call circadian rhythms. So circadian rhythms is how our bodies adjust to day and night. And so when when it starts getting night, we start getting sleepy. When day comes up, we're wide awake. But if you have very little sun and the sun is not giving you enough sun energy, how do you deal with that? And that's something that I've been working with various universities, trying to understand how best to create artificial light, and not just for humans, but also for plants. And so knowledge and skills that I need. So here's kind of a breakdown. There's electronic systems, a human element, testing and analysis. And each one I have to learn different things. For electronics and systems, I have to understand circuits. Obviously, I have to understand electronics design. And then putting the system together, putting the project together. It's just not a matter of just throwing everything together and making it work and hope for the best. You have to be very methodical in how you do things. And that's something that I've learned over the years. Understanding testing, testing for vibration, radiation effects, thermal effects. All this is important because if the electronics are not designed properly, they're not going to operate when you actually need them. And then analysis, figuring out, the data that I got, what does it tell me about the design? What does it tell me about the problem? That's something else that I have to learn is the analysis. And then the human element, something that recently I started to learn more and more about is understanding about the human element, because the human element is just as critical as the hardware and the software. The human has, certain, we can only see with two eyes, we can touch, we can hear with 2 ears, and we have a certain response to all this. But we have to understand how well this operates when we're trying to operate complicated systems. So this is what human computer interface is all about, is understanding not just the hardware and the software, but also the software systems. And so some of the coolest projects I've ever worked on, I have to say, is one of them was the voice command system, and I'm hoping here in a minute that I'll share a flight demonstration of it. But let me just briefly say that another one, not necessarily it was a project, was actually getting a patent award, one of the 4 that I've earned over the years, by John Young, who was the only astronaut that was involved with 3 different programs: the Gemini program in the 60s, the Apollo program, which he was one of the 12 that walked on the moon, and then he was the commander on the it was on the it was Columbia 1. It was the first flight of the space shuttle system. So let me just share with you, hopefully, a demonstration of the voice command system that I helped develop many years ago.
CS up here for the last several days in space, and we thought you'd like to see how it's been working for us. George Salazar and his crew down there at the Johnson Space Center have put together a system that allows us to control the cameras without using our hands. We can just use voice commands to talk to the cameras. So here's a quick demonstration on how they work. Voice command, activate.
Select the monitor, then a camera.
TV1, Delta. Action.
Action.
Right. Stop. Tilt up. Left. Stop. Right. Stop. Change rate. Tilt down. Stop. Change rate. Tilt down. Stop. Right. Stop. Too much. Too much. Too much. Zoom in. As you can see, it's a great system, and we really like it.
So that was a voice command system demonstration. I have to say that was assigned to me very early in my career, but I'm very thankful that NASA had confidence in me, being a very youngster, wet behind the ears youngster, to take on such a project. And so let me just kind of briefly talk about the moon and beyond, human exploration, to kind of wet your whiskers, if you will, about what's coming up for NASA. And obviously the Artemis program, which is returning to the moon, is a biggie. And so, but there's challenges ahead, and I'm just going to briefly just mention some of these challenges and not get into a lot of detail. But from the human standpoint, there's the challenges of gravity. There's different, the gravities associated with the moon, microgravity in space, and obviously the Mars and beyond. And there, things associated with balance disorder, fluid shifts in the sinuses. And so we have to, train the astronauts to deal with the gravity changes. Space radiation is a huge thing associated with the human body, and we're trying to figure out ways how to deal with the effects of space radiation. As we're learning, space radiation can affect the brain, which actually declines your cognitive abilities to, to do things like, touch, doing a touch screen, for example, ability to flip a switch and things of that sort. So we got to figure out ways how to get over that. Isolation, confinement, no doubt about it. That's a biggie. Being away from Earth, for million miles, millions of miles away is going to be a huge challenge. So we got to figure out, how do we keep the astronauts physiologically and psychologically, mentally healthy? And then the hostile or close environment. We got to deal with food, oxygen, water, and then habitat, for the astronauts to keep them safe. How are we going to do that? Those are major challenges. The distance from Earth, things like emergency medical conditions and things of that sort. How are we going to deal with that too as well? Those are some of the challenges just from the human standpoint. From a technology standpoint, and I'm just going to briefly step through these, is like, for example, power. It's going to be challenging to have even a small colony of maybe 4 to 6 astronauts on another planet, and powering all the things that are necessary for them that is needed for them to operate for a long period of time. Mining is a big thing, but mining is not so trivial because of, like, for example, the dust associated with the moon, Mars, is very abrasive, kind of like sandpaper, and it wears and tears on equipment. Robotics, we have to build better robotics to help humans for this deep space exploration. Human interfaces, that's an area that I'm heavily involved with, is, how can we build these better interfaces to deal with high-tech technology that we're going to be dealing with, automation, autonomous systems that basically think of their own. Well, that's fine, but we need to make sure that the astronaut understands what the autonomous system is thinking in the event the autonomous system goes nuts on us, and the astronaut has to take over. Habitats, to house them in a nice environment. Communications, the communications is, like, for example, going to Mars is going to be like 20 minutes one way, so 40 minutes round trip. As these delays get longer and longer, it's going to be more challenging for talking to loved ones and Mission Control Center. Entry, descent, and landing. As these systems get larger and larger, and because of the speeds that they're traveling to get to Mars and beyond, is quite challenging to try to slow them down and land them properly on another planet. Medical systems, that's going to be a huge challenge, as well as what we call in situ resource utilization. Fancy word for living off the land. In other words, let's get some soil, put it in here, and let's create water, or let's put some soil in here and create some soil that can grow plants so that we can eat. So all these are major challenges that astronauts are going to have to deal with in the future, and I'm hoping that many of you get involved with that. So you want to join the adventure? The very first thing is to graduate from high school, major in a STEM field, engineering, mathematics, computer science, medicine, and then intern, work at NASA while going to college. If there's a regular program for internship and a pathway. Pathway is the one that actually gets you to NASA after you've done at least 3 tours working for NASA. And the benefits, I have to say, these are the great benefits. You gain work experience, which actually benefited me for coming to work for NASA. And then you have a chance to evaluate what you want to choose, in your career. Maybe you start off in engineering and you decide that's not what I want to do. And so by working, you change your major into something you really want to do. And then you make yourself marketable for graduation. In other words, you got some experience and you got education training, which is 2 biggies. So a few words of advice. Family heritage is a motivation to do better. And I have to say that for myself, one of the motivations when I was struggling in school was I always thought about, where I came from, my family, my grandparents, my parents, and I just wanted to do better. Grades don't make the person, determination, hard work does. I think I'm a proof of that. You're going to make mistakes, and that's okay. Unfortunately, when you get tested, you make a mistake and they count points against you. That's something you have to kind of live and work with. But the important thing is to learn from those mistakes. I can't tell you how many mistakes I've done over the years. Even NASA has done quite a bit of mistakes over the years. And you fail only when you stop trying. Otherwise, it's just a setback. I hate to hear the word setback from people. If you stop trying, you failed. But as long as you continue, it's just a setback. I've had many setbacks in having to take classes over and things of that sort because I failed the first time. And then the only challenge you face are the ones that you put yourself into. And I have to say that for me, that was something that I had to overcome was the challenges that I put in front of myself. I can't do this because I come from a poor background. I can't do this because none of my parents had education. That's it's not excusable. Those are excuse. You can get over those. And so I challenge you guys if you're putting roadblocks in front of you to examine those roadblocks and basically say to yourself, I'm going to prove myself wrong. So that ends my presentation.
George, yeah, absolutely inspiring. Just we're so grateful that you were able to share your story and what you're doing for NASA. It truly is amazing, and the cool stuff you're working on now. That wow, full career. So everyone who's on the presentation here from George, you can use Slido Q&A. It should be on the right side of your screen, and you can enter in a question for George. We've got the first one here. It's more of a technical question for you, George. Talking about the computer languages that are used. We saw the astronaut controlling the camera and moving it around, and talk a little bit about the technology, the languages that you're using to control that. Oh, I think you're on mute. Did I lose you?
All right, here we go. All right. So that's a good question. At the time that we're developing those systems, microcontrollers were actually quite popular, and Motorola had a few. So the thing was that we didn't for this for the voice control system, we didn't use very fancy languages, to program the system. We were actually using some of the languages that were associated with the with the Motorola microcontrollers that we were using for this application. And so, we did use a little bit of C programming, but for the most part, we used, kind of like machine coding, to basically make the application very tight and try to reduce the likelihood of errors that usually are associated with something called compiling from one language to another. So it was compared to today's standards, quite primitive, but at the time very effective and quite beneficial actually in terms of being successful.
Thank you. We've got two additional questions. Lizelle asks, how long have you been working for NASA?
Oh, the pyramids were still being built. Actually, I've been I've been with NASA 38 years
Wow. Wow.
and
Um,
loved every minute of it.
Super. Angel asks, is it, how difficult is your job? I mean, I look at it and I'd say I couldn't do it, but how difficult is it for you?
It can be very difficult at times. I have to say that there were, times where, whew, I was saying, what am I getting myself into? Case in point, the voice command system. There were areas that I was not taught in school. Things about vibration, things about thermal effects associated with convection and conduction of heat. And so a lot of things, it's important to identify where your shortcomings are. And then, as I tell students, is know who to ask and know where to look. Those are two key elements. So it can be difficult, but the important thing is to, and I have to say that over the years, some of my colleagues that let's say they were high performing engineering students fessed up and told me that they had to leave their ego outside the door and fess up that they didn't know everything, and they had to find somebody that helped them to identify what is needed, to solve a problem, because you cannot solve a problem by yourself. It takes teamwork, and obviously teamwork is very critical at NASA. It's without teams, you're just not going to be successful in terms of a project. The voice command system, we had about somewhere in the vicinity a core of around six to eight people, but we also had, in addition to that, somewhere in the vicinity of 45 to 50 people, but everybody was just important, and it was a team effort. As I tell students, when you're working on a team or when you're working on a project at NASA, it's not like and I use the analogy of a quarterback in football, that sometimes the quarterback is given all the glamour of being the star quarterback for winning touchdowns and all this kind of stuff, but they forget about the linemen that are blocking for him. So if the lineman did not block for him, I suspect that he would not be able to complete a pass. And so it's the same thing in the team. Everybody's important, and so it's a team effort.
Super. You're right. Teamwork. We're hearing that over and over again, that the NASA folks really work in large teams, complex teams, and everybody has a specialty, but they're all learning from each other. Another question from Isabel is, why is NASA, if I can interpret a little bit, why is NASA implementing voice control devices? Why is that important? I know Alexa and Siri, we do it in our homes, but why is NASA doing it?
Well, that's a good question. So, as we start going further into space, because of the lack, let's say the time delays of transmitting voice to a mission to Mars and even and beyond gets longer and longer, we can no longer depend on mission control like we are accustomed to seeing on right now. We see space station where space station is talking to the astronauts on International Space Station, and the delays are just like a quarter second, 0.25 seconds. It's very short. Even going to the moon is going to be about 1.2-second delay. Not too bad. But as we start going to Moon, Mars, and beyond, the delays get longer and longer. So what does that mean? That means that we're going to have to have more intelligent systems on board these spacecrafts. Well, because of a small crew, maybe 4, maybe 5 people, it's going to be very challenging for this crew, to control all these spacecraft systems. And so we basically, what voice control does is give the astronaut an extra pair of hands, if you will, and along with the display, actually an extra pair of eyes. And so by implementing voice control for some of the deep space missions, we've actually improved the, let's call it the efficiency of an astronaut going into deep space missions. So voice control provides that extra capability, if you will, for controlling complex systems. And the thing about voice communications, for the most part, it's the most natural form of communications that we know, right? We talk to humans. It's very easy to, obviously communicate with humans. Machines can be a little bit different, but if we can communicate with them in a verbal fashion, it simplifies the communications. It simplifies the interface with a complex machine.
Wow. Isabel submitted another question. What part of your job do you like the most?
Oh, wow. There's so many parts, but let me just say that now that, after being with NASA, for many, many moons, my part right now is my enjoyment is all the knowledge that I've gathered is trying to give it back to the students. That's what I enjoy the most. The more I can give back to students, the happier it makes me, because I'm giving back. I'm trying to help instill the motivation, the inspiration, if you will, for those students that are struggling in school like I did, and saying, no, you can do it, and you can become a very important member of an engineering team like I have at NASA. And so that's, to me, is the most important part right now.
Wow, thank you. If there's one more question, we can take one more question if you get it typed into the screen fast enough. Otherwise, George, first of all, thank you very much for sharing your knowledge, your wisdom, your enthusiasm. You do it's amazing work. We're always awed by talking to you. So thank you again for working with us.
My pleasure.
On behalf of Maker Faire Milwaukee, Gearbox Labs here, we're super appreciative of it. The Office of STEM Engagement introduced us to you at NASA, so we really are very appreciative of their work. And barring, I'm not seeing another question pop up here, but again, thank you very much. We look forward to working with you more. And for those of you on this live presentation, we have recorded this. We will be posting it probably in a couple weeks. And then you'll be able to look back at George's presentation. And again, thank you very much. Any final words of wisdom for our audience?
Oh, for me?
Yes.
I guess my final words of wisdom, in addition to what I just mentioned in my presentation, is stay inquisitive. Stay let's say to keep on learning. There's so much to learn, so little time. So take advantage of every minute you can in terms of learning and understanding the world, understanding how you can help make the world a better place to live.
Thank you. Thank you. With that, I want to thank everybody. We are just at time. So have a good rest of your day. And we look forward to seeing you again on another presentation. But thank you, George. Take care.
Thank you. Bye-bye.
Bye-bye.